Hi guys, this is Yashpreet Bathla. I am currently SD2 at TESL. So today we have some interesting topic to see. It's called flickering user interfaces. So before going ahead, let's start for the agenda. What will be the agenda of the meeting? Right. So okay, like when your user interface flickers more than your confidence during a live demo, something like this happens. So yeah, I'm a little anxious, but let's start. Okay, so yeah, the topic for today is avoid flickering user interfaces and the how browser paints. Right, let's go and see the real agendas. Right, so the first topic we'll be discussing what is the flickering user interface. Second, we'll be deep dive into what is a browser painting or how it happens. Then we'll go for React lifecycle, and then at the last, I'll introduce to a React hook called use layout effect. So let's go. Okay, so what is a flickering UI? Flickering user interfaces refers to a visual issue where part of web page, it appears to blink, flash, or reappear and disappear. It is called flickering. Something like this, maybe, or this. But luckily, our browsers have evolved in a very good way, and we really don't see these kind of jitters or flickers in the UIs now. So yeah, let's go ahead. So why does the UI flicker, right? And let's understand how browser actually paints, right? So let's go ahead. Yeah, so as almost all of you might have heard of, like, okay, there's a main stack in the browser, then there's micro task queue, macro task queue, but the thing that most people might have not have heard of is a render queue, right? So browser actually maintains these queues in order to do a lot of JS execution, rendering, and a lot of things on the browser. But it actually also maintains a render queue in order to maintain how the browser paints on the screen. Right. So let's discuss the render queue because I think the other queues are well known and everyone knows about it. Right. So inside the render queue, you have few steps called execution of request animation frame. So this is a callback provided by browser to the users in order to run that all the animations, everything just before the like painting execution starts. So if you want to run any animation, any important thing that you want to change, you can just use a request animation frame and you can do any calculation or any changes in that, right? Then second is called styling, right? So styling is like browser recalculates styles for elements that have changed in the browser. Then the third thing is called layouting. So the layouting looks like browser computes the new positions for the elements, and sizes of the elements where it can go. Then the fourth step is very important step. It's called painting, right? The browser paints the elements to the screen based on the render tree, right? This can involve multiple layers, especially for complex animations or effects. It actually paints a lot of screens together, right? And then at the last step, it's called composite. Right, so composite is like the things that we have done till now, till painting. We might have multiple paint screens. It actually reuses some of the paint screens so that it doesn't, paint everything again and again, even the frames are same. So it do all the optimizations and bringing everything together at the composite step. Cool. So yeah, I think now we know the problem. There's a problem of flickering UI, right? And we know the problem statement. Let's go in depth and let's understand, like, okay, how browser actually works. So the browser, if you see this kind of video on the browser, right? So mostly browsers maintain 60 FPS in general. It try to maintain that, although like it fails to maintain every time almost. But mostly it tries to maintain for a 60 FPS. What does a 60 FPS mean, right? So the basic meaning of 60 FPS is it is painting 60 frames per second on the screen so that you can see a 60 frame per second motion on the screen. So if you do some mathematics, basic mathematics, for painting every frame to maintain a 60 FPS, you need to paint in a 16.6 milliseconds. So browser might be doing this kind of things behind the scenes in order to paint just the video that we just saw, right? So let's see like how this 16.6 millisecond is broken down into, like what does this comprise of, right? So browser, like almost all the browsers take, obviously, it depends on the like your machine, like what is the capability of your machine. But in general, it takes around 1 millisecond to paint anything on the browser, right? And rest 15.6 milliseconds, browser leaves for the JS code execution. But there can be a case where the JS code execution might be like ending in 3 milliseconds, then obviously it will paint at the 4th millisecond, but it might not paint if there's no change in frames. So let's go deep dive in like what is this JS code execution, right? So this JS code execution might have these steps, the steps that we discussed. It's called call stack, microtask queue, macrotask queue, and the painting remains at the last, at least for now. So let's assume that call stack is taking 3 milliseconds, around 3 milliseconds. The microtask is taking 7 milliseconds. Now the browser have some choices to make, okay? So like these two tasks cannot be deprioritized for a browser because it might be having some important tasks like promises, and the call stack is obviously the most important thing that you want to run JavaScript. But the macrotask queue, so IO operations, set timeout, set intervals, things like that can be deprioritized a little because a user should not be waiting on the screen, just waiting for a IO button to work, right? So what it does sometimes it sees a fear of losing the frame rate, so it just actually paints before the macrotask queue. So it changes the orders, and if you try reloading in your code, you can actually see this pattern of like this painting happening before the macrotask queue or like after the macrotask queue, right? So this call stack might take this time. Now the microtask queue taking is 10 milliseconds, so it's almost 13 milliseconds now. The browser have only 2 milliseconds, so it will say, okay, I don't want to lose the frame rate. So what I'll do, I'll quickly just paint quickly, and then I'll do the microtask and do the next executions. So this is totally depending on the browser, right? There's one cool video on the YouTube I'll put in the appendix. For that, you can see how this actually internally works. But yeah, for the overview, we actually have this understanding that browser can decide on this part, right? So yeah, this is cool. But what happens if the the call stack or the microtask queue takes a lot of time, right? There's a possibility, right? I have a thread going on in the code that takes a lot of time, right? What will the browser do? So that's where the problem comes, right? So for example, if the microtask queue is having 3 tasks inside it, and it is taking around 500 milliseconds, the UI will be blocked. There will be no painting on the browser. You will not see any of it, right? And there's a possibility that it paints initially, and in the second render or in the second run, it encounters these kind of big tasks, so the browser will be blocked. So that's why you see a lot of bad websites or not good websites that the interaction of the buttons gets disabled, or you can't click it, and things like that happens. So yeah, something like this you try on websites, but yeah. Yeah, so that was about the browser, but we are at the React conference, right? We would also like to know, like, okay, these are cool concepts, microtask queue, macrotask queue, we know it, but how, in the terms of React, I also want to know, right, how the things goes. So inside React, right, we know the initial render or rendering process. So at the initial render, what the browser does, it actually tries to paint, right? So the initial painting happens just after the initial render. Then there is a state change, re-render, paint, and it continues altogether after that, because as you change the state, there will be state changes and painting happens again. But how will it look, right? Let's see some example. So for example, I have a circle coordinates, and I'm fetching it from API, I'm calculating, I'm doing some stuff. This is just a like an easy way of understanding how this will be visible. So you might have some coordinates of a circle. You show that like a partial circle on the screen, and then there is a state change. You calculate the whole coordinates of the circle, and something like this happens, right? I know there will be a very small lag in both of this, like almost real time, but when the page scales, you have a lot of heavy components on your application, then this will actually show very prominently on the screen, right? So this is why exactly UI flickers, or this is why flickering on UI for React happens, or in general things happens, right? So yeah, that is like a very basic thing. And so everyone, I want to cheer from back, and everyone who might have used use effect for changing DOM manipulations or like doing DOM calculations. Anyone have done that? Cool, I see some people. Okay, so yeah, use effect is like every React developer's savior for everything. Anything changes, you just put it in dependencies, you do some calculations, you do a lot of work, and you end up using the use effect at every place for every re-rendering kind of thing, right? So let's see that where does the use effect lies, right? So just after the initial render, the painting happens. Then there is a use effect that actually runs just after the painting. And then there is state change, re-render, and painting happens again, right? But do you see any problem here, right? Anyone? Like if you see that the first painting is happening just before the use effect, so if you're doing any changes inside this, it will be actually not visible, right? It will be having again paint, and then till that time you'll see some props. If something is changing inside the use effect, you will see, oh, okay, things are changing after the first use effect is running. So we sometimes want to avoid that, and I wish React had some power or like some hook or some kind of capability that it gives me in order to not use this. So, or like delay the first paint if I can, right? So you see some flickering over here. Do you see that? Yes? Yes. So the 0 to calculation, obviously you can use some intermediary states, things like that. But for simplification, I'm just showing that for initial props, you're having 0. You can obviously initialize with other things. But just saying, from 0, you calculate something, you show that. But there's a flicker on the UI, right? And this can be a use case of like a problem use case where I don't want to, show the 0 in between. It can be a cost of a user or like, some kind of billing data, right? So, okay, I want some power. React, can you help me? So, yes, it is called use layout effect, right? It is in the same manner how you use a use effect. It actually also here to your dependencies, runs to your lifecycle methods, and it works, right? So let's see where does the use layout effect actually happens in the painting cycle. So after the initial render, use layout effect pushes the first paint after the re-rendering happens. So if there's no re-rendering, only the initial thing is there, then after the just use layout effect, you will see the paint, right? So this initial render is the thing that we obviously saw at the 0 case. Then the use layout effect will run. If you want to do any DOM changes, the calculation, anything like that, you can do over there, right? So yeah, this is what about use layout effect is. Okay, talk is cheap. Show me the code, okay? So let's just try to see some examples, some real-world examples as well, like where does the thing happens. So, yeah. Cool. Okay. So, yes, we have a first app, right? Let's see some console logs. So I told you guys that request animation frame is the you can say signal for telling me, okay, the painting process has started. So after the first console log, right, you see there, like the main call stack happens, the queuing of microtask happens. There's a function in the, or the API in the DOM that you can use for the queuing microtask. So assume that you're having a queuing microtask. Then after that, request animation frame runs, like the painting happens. Post that, you see a use effect executed. I want something that runs before the request animation frame so that I can see I can change some DOM properties, I can change something on the screen so that I can calculate and show on the painting side. Right, so let me quickly show you one more thing. Okay, so now we have second and we reload. Right, so you see a use layout effect over there. It actually gets prioritized even over microtask queue, right? So this is a very powerful hook that you can use, but it comes with some cons as well that I'll discuss in the last. But yeah, this whole process will be a good proof of concept for you guys, okay? The use layout effect actually runs before the painting, the request animation frame. So let me quickly show you some real-world examples. I think too much of theory. Now we need some real-world examples, okay? So cool, let's go ahead. So let me show you the example, okay? Anyone see some jittering over there? Like if I reload, right? You see some jittering, right? That content is going over down. So this sticky header, right? This sticky header is a content that is coming from API, but this whole header, I want to put some height, and then on that height, I want some padding on this content, right? I want to move this content to some ads, some use case, right? How will I do that? I will have to paint that content, I can use some dummy heights, but it will be better that if we have this sticky headers height, real height, and then we change the padding for this, right? But how do we do that, right? If we are using a use effect, just I mentioned you, so how this will look like. This, we have a use effect. We are using the offset height for that current div, the sticky header. And this height can change depending on the browser, browser font, browser content. It can change a lot. So that's why we are using that kind of approach. So here we use the padding over there with the header height, right? But here we are using a use effect over here. But now we want to do that before the paint, right? It's a use case. We don't want the user to see that jittering over there. So what we can do, we can just simply make it a use layout effect. Yep. And we save it. We go back. And now we reload. Okay, there's no jittering over there. So there's no jittering in this content, but you see in the heavy component because we haven't fixed it. So that is there. And yeah, so this is like an example that I wanted to show. I have one more example. I'll quickly show that. So this is a very valid use case that everyone uses like a dynamic carousel, right? In your use cases. But so there's a possibility that you might have a container where you want to show the items, right? And so in that content, I want to make the items width as 1/3 of it, right? Every time it can be of any width. So I want to set it at the runtime, right? Like at the time when things are running. So if I try to reload, did you see a jitter over there? So that jitter is coming because the DOM is trying to paint everything, and it is trying to check the width of the container, and then making this item's width as 1/3 of that container. And that sort of like is a big problem for users, right? To see that jittering over the application. How can we fix it? I think the same power as I mentioned you. So what we can do, we can just make it a use layout effect again, and yep, we are good to go. If we try to reload, now things will be perfect for you guys, and it will be working pretty fine. But I think if it was so easy to use, why not everyone is using it, right? So let me come back to the point. So yeah, so as I showed you first example, second example, it was pretty evident how we showed the painting at the last. But yeah, so we know like flickering can be solved using layout effect, but now like we have a flickering UI, we had a problem, we were panicking. Okay, let's use effect. But now the whole UI is blocked. Why? As I mentioned, right, UI can be blocked. The first paint will be also blocked. So if you have a very big operation in the use layout effect, it will block the whole UI, and we don't want that. So it's a very big disclaimer. Whenever you use a use layout effect, it should be, because it runs synchronously and after DOM mutations, can block the browser painting. The browser will not paint, it will be a blank screen. So use it only for quick operations that need to be done before the browser repaints. So yeah, this was it from my guys, and thank you so much. And yep, thank you. Yeah, this is a link tree. Appendix at the last. So this appendix, you can refer to the articles and all that I have. So yeah, cool. And yeah, thank you.